Hello everyone, welcome to day 30 and final session of our machine learning internship, and I welcome you all. And over this internship of 30 days we have covered a lot of topics, starting from the roadmap and then Python introduction, some contents about the exploratory data analysis with pandas, and then using visualization tools, the libraries for data analytics, and then machine learning concepts, and then we went into machine learning algorithms. So basic machine learning projects we have done, and then seen an introduction about deep learning, and then also we have went into the next part, which is time series analysis, and then moving towards a project with time series models like Arimas, Arimax, and also with LSTM. And then we started introduction about NLP. We have seen a project with NLP which uses machine learning algorithm, and here we are going to see another project which will be Twitter sentiment analysis, which uses LSTM, and the data we have is Twitter data. Every data we will be having Twitter sentiment, we will be having output, and we need to map it to it. So that we will see in this final session on day 30. So starting with this project, which is Twitter sentiment analysis. So what is this project? We'll see an introduction about it. So Twitter is a popular social networking website where users post and interact with messages known as tweets. And this serves as a mean for individuals to express their thoughts or feelings. They used to send tweets, right? And various different parties such as consumers and marketers have done sentiment analysis, such as like the tweets by the people, or like on what basis it is, okay, to get insights into products or to conduct market analysis and so on. So what we are going to do is we are going to conduct a sentiment analysis from the tweet in Twitter. So we will be attempting to conduct sentiment analysis on tweets using various different machine learning algorithms, and we'll also apply neural networks here, and we attempt to classify the polarity of the tweet, and finally we'll be finding whether the message is positive or negative. So we have a data set for this. We are going to do it with Python. So the overview will be pre-processing the text using NLTK first. Okay, so this data set will be a text data set where you will be having all the tweets, and whether it is a positive one or negative one, we will have that in a separate column. So when you have a text, you have to pre-process it, right? For that, human language, we already learned about NLTK, how to use it, and regular expressions to remove unwanted things from the messages. And finally, once we pre-process it, we will make it ready, and then finally we'll give it to the machine learning algorithms, and then also using neural networks. So we'll start it with this in Google Colab. I'll open it. So here I have loaded my dataset twitter.csv, and let me run this, importing all the necessary requirements: NumPy, Pandas, Matplotlib, scikit-learn, and I'm going to use Pandas to read the CSV file twitter.csv, and once it is loaded, we'll use the head function to see the first 5 rows. So this is the dataset we are having. So it is having a column known as ID column, which is like the label of it, and no use for it. And the label column where you are having zeros and ones will be having, and these label columns are like, if it is 0 then it is a positive, and 1 means it's a negative tweet, like that. So this is the label we will be using for the y value or the output, and this is like binary class prediction problem. Okay, it is like binary classification problem, whether the model or the algorithm or the neural network should predict whether it is 0 or 1 in the end. And these are the tweets where we are having all the tweets, and we are having some unnecessary things, right? We are having hashtags, we are having @ the usernames. So we have to pre-process it, and once we done it, we can give this, we can convert it into numerical form with the help of bag of words, or using count vectorizer, or then using TF-IDF vectorizer, and then we can later give it to machine learning algorithms or neural networks. So in case we are going to use it in neural network, then since it is a text data set, it is better to go on with RNN, recurrent neural networks, and in that we will be using LSTM today. Let's get information about our data set. Here we are having, okay, so totally there are 31,962 entries. So this is a very big data set, okay, and totally there are 3 columns. So ID column, there won't be any use. We have to focus in these 2 columns where the label will be the outcome, and the tweet is the major thing. We will have to pre-process it. So this is a big data set and we are going to use it. So first we will be using regular expression. I am creating a function here. We are already learned it. So we are going to use regular expression to remove some patterns. Okay. So since I need to remove, if I want to make this common, I can create functions and use this block of code as a reusable one. Okay. So I'm creating a function commonly so that later I can remove it. So what I'm doing here is I'm creating a function using the def keyword and I'm giving a name remove underscore patterns. Okay. So I have to pass two arguments here. The first one will be the input text and the next one will be the pattern which I want to remove. So if I pass these two things, the pattern will be passed here in find all. Okay. I'm using regular expression to find the pattern in the text which they are giving. So this will find the pattern, and we already seen this in example while seeing about regular expression. I'm using for loop in this, and what I'm doing is I'm substituting. Okay, I'm substituting with an empty space. So if I want to remove something, what I'm doing is I'm going to search for some pattern. If that is found, I'm just going to replace it with empty string, which means those things will be removed. Okay, and here the input text will be passed. This will substitute, and finally once this loop is ended, we'll be returning with the input text. Okay, so this input text which I entered now will be substituted. Unwanted things will be substituted with empty strings, and you will get the output in this input underscore text. We'll run this. This is a function we haven't called it yet. So next I'm going to call it. So if I need to call it, I have to call the name of the function remove underscore pattern, and I have to pass these things. And here I'm calling the data set, and I'm giving a new label. Okay, the new column name tidy underscore tweet. So I'm cleaning it and storing it there. We are having only tweet column. So if I give a new name, another column will get added here. So in that column, what I'm doing is I'm just storing. Okay, I'm just calling the remove pattern, remove underscore pattern. So remove underscore pattern is the function I have created. I have to pass two things. One is the input data, and next one is the pattern I want to find. The input data will be, I have to change this, right? So what I'm doing is I'm calling the variable name data, and I'm passing this column alone as the input. Okay, as the input text I'm passing this, and the pattern I'm going to find is I'm going to find this. Okay, at the rate with slash w. This backward slash w, which means any characters, okay, any letters or numbers, and this at the rate, okay, this in the text, right? So we are having this usernames which will be in the at rate. Okay, so if I want to remove that, I am going to search for the combination where at the rate and some texts are there. If that is found, I am going to use this remove pattern where I will be replacing it with empty strings. So what will happen is if I run this, I'll be getting a new column where this at the rate and that username will be removed. We'll run this, and let me show you the head of it, data.head. I'll run this. See here we got a new column and name tidy underscore tweet where at the rate user or these usernames have been removed. Okay, so this is first 5. You can visualize the last 5 also. In every place we are passing that. In all places those things with at the rate and word will be removed. Okay, we are having some unnecessary things also here. So these things are removed here. So there won't be any at the rate. So we are having some other things also. We will remove that in the further process. Now we have removed at the rate. Okay, usernames. So next, what I am going to do is in the tail also we see, right? So some unwanted things are unrecognized letters are there. So what I am going to do is I am going to remove anything other than letters and hashtags. Okay, if something else is present, I am going to remove it. So how I am going to do is I'm going to call. Okay, I'm going to call this. I'm going to call this column where I have removed the at the rate. So I'm going to call that column, and I'm storing it again in that. I'm calling the string and I'm replacing it with this one. So what this will do is this will check for small a to z and capital A to z and hashtag. Okay, but I have told you I don't want to remove these things. I want to remove things other than that. Okay, to mention that we are using this caret symbol. Okay, this cap symbol, this caret cap symbol will remove, this is the opposite of it. Okay, so it will search for a to z, small a to z, capital A to z and hashtags. So if these things, and I'm mentioning the cap, so other than these things will be replaced with empty string. So if this is found, okay, if this is found, it is going to leave it because of this one. So other than that, if anything is present, it is going to be replaced with empty strings. And I'll run this. Let me show you now. Let us see data.head and see whether it is changed or not. This should remove everything other than text and with hashtags. Okay, so we are having hashtags and we are having text. Let us see the tail and let us see whether that unwanted thing is present there or not. Okay, now see here, there these things, these unnecessary things have been removed and only hashtags and text are present in our data set now in this column. So now next what I'm going to do is I'm going to search for, like, if the length is greater than 3, okay, if the words inside this, I'm going to use lambda function to apply this. I'll tell you what is happening here and then I'll explain you the code. So I'm going to search for something which is like greater than 3. If the length of the word is greater than 3, I'm going to leave it. Okay, if it is less than 3, I'm going to remove it. Okay, only if it is greater than 3, then only it will got added here. So I'm going to use, like, I'm not applying it in this column and storing it in that column itself. Now applying lambda function directly, where I'm asking for x, and what I'm doing is x will be the values which is present in each column here. So it will be passed here. So it will go into this for loop. Okay, so in for w in x dot split, this x, okay, this will be a sentence, right? So if this is passing on, it will be splitted and centered into each sentence, where it will check for is the length is greater than 3. So this on won't be going inside, and the won't be going inside. Only if it is greater than 3, it will pass inside, where I am asking for w. Okay, and that w I am joining it. Other than things, I am removing it with empty strings. Okay, so only if it is greater than 3, I am going to add it here. Okay, if there are 3 more words, I am going to leave a space and I am joining it, and I am applying it here in this column itself. So if I run this now, if anything is less than 3, that won't be present there. So we'll see this tail again. I hope you can see those small words have been removed. Only hashtags and the lengthy sentences which has length like from 4, we will be having that in our tweet now. Okay, you can see the head also. So those things have been removed. Now we are having some processed text in this column tidy underscore tweet. And next what I'm going to do is I'm going to split them. Okay, so instead of calling NLTK tokenize sent or word tokenize, I'm just directly applying it with lambda, where I'm just using dot split from string. So it will split each sentence into like different words. We'll run this and see. So I'm storing it in the variable tokenized tweet. I'm not appending it here. I'm just storing it in a variable where it should contain a list with each word separately in a list. Okay, in this column. So this contains a separate list where each word is element like that. And now I'm calling NLTK. So I'm importing NLTK, and in that I'm asking for stem and porter stemma. I'm importing everything present there. And in that I'm going to use porter stemma. I'm creating an object for it in the variable stemma. So this porter stemma, what it will do? It will do stemming. Stemming is finding the root word. Okay. So I'm applying it with the help of lambda here, and this x is applied here. Okay, for I present in x. Okay. So the x is nothing but for each rows, this value will be the x, and it is passed here in for loop. So the value of I will be each word. Okay, so the next time it will be dysfunctional, then self is something like that. Okay, and for that I, each word I'm just stemming it and adding it here. Okay, I'm storing it in this tokenized tweet itself. Now if I run this, let it run. It's running. Okay, now those all the words have been converted into stemmed. Okay, those things have been stemmed. Try to find the root word, and those words have been present here now. Next, what I'm doing here is I'm calling for loop here for I in the range length of tokenized tweet. So these things are separate right now. I'm going to combine them into I'm going to convert them back into the column. So to do that, this is in the form of a list. Okay, so I'm just joining it in for loop. This will run every time. This for loops, the first time it will like combine all these things into a sentence. Next time it will combine all these things in the sentence. So like that it will run and store it in this column again. So if I run this, let us see our data set now. The stemmed word have been replaced in the tidy tweet and in the form of a sentence. You cannot add a list directly, right? So we are combining it using this dot join. We already seen that while we study NLTK, and we are adding it here. Okay, with stemmed word. Next, just I'm going to use this all words to like get all the words which is present. If I run this, I'm just joining it in a sentence, so I'll be getting like a big sentence where all the words are combined. Okay, these are the entire things which is present there in our data set. So it will keep on going because it is a very lengthy data set, and you'll having all the words which is present now. Still it is going. You can see that if you want. I'll just make sure it's not disturbing us. And next, I'm just using, what I'm going to do is I'm just going to separate the normal words and negative words. Okay, so just for our understanding, I'm calling like only selecting the label where it is 0. So these are normal words, and I'm going to get that from this column. Okay, so for text in data, in this I'm going to use the loop, and this will be stored in the variable text, and in that if it is 0 only it is going to get, and I'm going to join them and store it here in the normal words. So you can see that also I can print the normal words, so it will be lengthy. Okay, I'll run this. We can also get the length of it actually, to even though if it's visualizing you cannot see, right? So with length I can run like what is the length of all words. Okay, totally these much words are present in like all over, and if I try to like, it is lengthy, right? We'll try to see what is the length of it. Okay, so I'll type here length. I'll run this. This should return the length totally. So these are like normal words, and if you go on with negative words you can get that also. I'll print that. So when the label is 1, label is nothing but the label column where you are getting 0 or 1, right? The output. So I'm just selecting them based on it. And this for loop, this is a short form, we already learned it. And print length of negative words. I'll run this too. So we should get, so these are the negative words which is present in our, like in that negative tweet they are having these much words. You can tell that. So next I'm creating another function using def keyword. This is to extract the hashtags. Okay, to visualize what all the hashtags which is present, and to find that, what I'm doing is I'm going to like similar to @ we are searching it with hash. Okay, and whatever the words there with hashtag in front, I'm going to remove that and I'm appending it in this list hashtags. Okay, using for loop I'm getting it, whatever the x I'm passing, x should be the column. Okay, so I'm going to run this. So this is a function which will finally return you the list. I'm going to return this here. So what I'm going to do is I'm going to remove only, like I have to pass this x, right? So the x will be the values which I'll be removing. So I'm going to give them separately. So if the label is 0, I'm going to give them separately only that column, only that rows which contains 0. In the tidy tweet I'm going to give that, and I'm going to store it in ht regular, and I'm going to give whichever it is 1, I'm going to give that hashtags to ht negative, hashtag negative, and here I am summing it so you can find the length of it totally. It's running, so it is a big data set, so it will take you time, and you can see the negative, what all present here. These are the like things, hashtags present in the negative if the output is negative. Okay, so finally now we have pre-processed everything. The next should be like converting this into numerical form and then giving it to the machine. That's what is the pending things, because we have done removing the username or unwanted things present, or like we done stemming and we removed the hashtags now. So next what I'm going to do is I'm going to separate the x and y, where the x will be the column where we have done everything, the tidy tweet, and in y I'm going to give the label which is the outcome. I'll run this. Let us see the shape of it, x and y. Okay, and I'm going to pass the x data in a list, and I'll find what is the length of it too. So totally 31962 have been present in x and in y. Okay, since it is one column, we are getting this, and output also one column, right? So next we are going to use algorithms to do this. So this is in a text format. We have done the pre-processing. Now I have to convert this into bag of words with the help of count vectorizer from sklearn.feature_extraction.text. Okay, I have to do this, and let's start it. So I'm creating a variable here, and I'm calling the count vectorizer. I'm giving the token pattern. I'm giving it as a regular string, and I'm going to find any other words present there. So there is no stop words, and I'm giving the range, and the analyzer here I'm going to set this word, and I'm going to ask to fit and transform it. I'm creating a class here, sorry, object here, passing all the necessary things. I'm converting it here. I'll run this. So this variable bow should fit and transform everything and store it here. I'll run this. Okay, so this bow will have BOW will have all the things in numerical format. We'll see. So this won't be executed since we are not converting into array. We are just directly going to give. So these much kind of data which is present there. So now these will be the x values, and the y values will be in the variable y output. And I'm going to give this to the model. So I'm importing linear model logistic regression first. I'm going to give that, since it is a classification problem. Logistic regression is one of the important classification algorithm. Okay, we'll give this problem to logistic regression, and I'm importing train test split because we haven't split that, and finally the metrics to analyze the score. And I'm creating variables here, x train. So I'm passing bow, right? So I'm just mentioning that. So bag of words, x train, x validation. So we can give this like validation or test. Okay, so everything is fine. I'm just give it validation itself, and I'm passing I'm calling for train test split, and I'm passing bag of words, the numerical format here, and the label column here, the output, and I'm setting the random state as 42, and the test size is 0.1 here. So next I'm creating a variable object for this class logistic regression, and I'm fitting it. Fitting will be the training part while I give the questions and answers to the machine. I'm giving the x train and y train to the machine. Okay. And next what I'm doing is, once it is trained, I'm going to get a prediction using this variable dot predict, and I'm going to pass the testing features. So this should be x test. I'm passing here, and I can compare it with the help of score. Okay. I can pass the accuracy score, y original value, and y predicted value. You can see here, right? This is the predicted one, this is the original one from here, and I'm just printing the score finally with 100. Let's run this. This should separate them, and run the fit it and predict it, and we'll run this. So it's running. So the accuracy we are getting here is 94.93, which is very good, high accuracy. And next I'm going to use another classifying model where I'm going to use sklearn.ensemble import random forest classifier. So it is a tree shaped, it contains many decision trees, and based on the average outcome it will take the output. Okay, what is the maximum vote, based on it will give the output. I'm creating in the variable random f, and I am going to create a class here, store this in the object random, and finally I'm using it to fit the values, and then I'm predicting it, and I'm comparing it with the original value. Okay, and printing the score finally. Let me run this. So this will take some time because it is computationally expensive. Random forest classifier, we'll wait till that. We got around 95% in random forest classifier, and then we are going to run support vector machine. So in that support vector classifier, I'm storing it in S, and I'm fitting it, and then I'm predicting with it, and finally calculating the accuracy score. Let's wait for it to run. In SVM we got around 94%. So among these, random forest classifier got us some high output, high accuracy. Then we will be moving on into LSTM. So using neural networks we are going to find So we are going to do this using deep learning neural networks, and in RNN for text data it is better to use LSTM. So what I am doing here is I am going to pass TF-IDF here to convert everything into numerical form. The column data tidy tweet I am going to convert them to numerical form, and I am going to store them in array to give this to LSTM, so neural network. So I am calling TF-IDF vectorizer, and I am setting the token pattern where I am going to find some text here, and I am not going to set any stop words because there is no stop words. We have removed that unnecessary words, and setting here the range, and analyzer I am setting it to word, and I am calling TF-IDF vectorizer to fit and transform this column to array. So now it will be in the array format. I will run this. So before giving that to our neural networks, what we have to do is we have to make them in equal length. Okay, so you see here, when you see your text, okay, I'll show you. So these things are different length, right? The first one may be like combined of 8 words, or see here it is only with 3 words. So in such cases, like this will be replaced with numbers now with count vectorizer, but they are of unequal length. To make them equal length, what we are going to do is we are going to do padding. So what this padding will do is, so we are going to import from keras.utils import pad underscore sequences. So this will do padding. So I am going to set the maximum length as 15. So this will be passed here 15. So all the text now, all the rows will have 15 as the length of it. And what I am going to pass is the thing I have converted using TF-IDF, right? So I am going to pass that here, and I am setting the padding pre here, which means like if it is only 3 word, the length of it is 3, but here I am setting it to 15, which means like remaining 12 length, okay, 12 zeros will be added in front of this. That's what the meaning of padding. So it will add zeros to make it totally 15 in the length total count. So it will do it in every row so that the overall will get 15 as the length of every column. So I'll run this, and I am storing it in the X. So this is the X, right? So I need to pass it as X, and Y I am calling the Y, converting it into array, and I am splitting X train, Y train, setting the random state and test size, and then I am going to create neural networks. To create neural network, we need required things. I am going to import what all the required things: keras, sequential to create the model, dense layer, ReLU, dropout, and LSTM for RNN neural network. Embedding, so we have seen this when we learn about neural networks. This embedding has to be done when you are passing text data. So it will give, okay, it will normalize everything and give it in a batch to the LSTM layer. So this should be the first layer. So we'll start, and I am calling the sequential here in the variable model. I am storing it in the variable model, and I am calling model to add. So first layer will be the embedding layer, and the input dimension is, I am going to set that to 10,000. So 10,000 words will be passed in the input, and the output, this embedding will, what it will do is the output I am setting here to 200. So the output, it will convert them into 200 size, and the input length I am passing here is 15, and this 15 comes from the padding we have done. So we have set it to 15. If you like miscalculate and give wrong input, so you will get error. And what I am doing is this embedding will do and give output in the shape 200. So I am going to pass it to the LSTM layer. I have set it this to 100, and this LSTM will convert, okay, it will do the processing and then give it to the dense output layer. So this is the layer where all the process will happen in the neural network, and this finally, this dense layer is the output layer where the output is 1, which means you will get binary class. So I am setting the neuron 1 here, and activation is sigmoid to predict whether it is 0 or 1. Since it is a binary classification, once we finish this model building, we are going to call model.compile, where I have to set the loss. I am setting it to binary cross entropy, optimizer its Adam, and metrics is accuracy. Once I complete all this, I am going to ask for the printing the summary of the model, and finally, once you call this model.summary, we haven't seen this. This will give you a summary of our model, and then it will fit. I am calling to fit it X train and Y train, which I have splitted for this one, and I am going to pass the batch size as 64, and epochs I am setting it to 5. We will run this and see what is the output. So we are getting the summary. This is the summary it will look like. So it will tell what all the parameters there, and this is the running of the epochs. Okay, you see here it is running, right? So this is what epoch is. So it will run batch wise and it will run 5 times. So the accuracy may increase or decrease, and based on it you have to modify it. This will run 5. Once it will complete the 5 epoch, you will be like the training part will be over, and here it is splitting them into 450 parts and running them one by one. We got accuracy of 0.9281. This is how you can run a neural network. You can get the summary of it, and then you can, once you fit it, it will go on to run the epoch which you have set it here. So like they may people like set based on the requirement, they may set 20, 30, even 100, and it will run till that. So the accuracy over time may increase or decrease, and based on that you have to modify your parameters which you have set it here. And it's running. We'll wait for it to complete. So the next time we got some improved accuracy from 0.9281 to it increased to 0.9295, and it is running the third epoch. We'll analyze here the shape. Okay, the output shape it's 15,200 and the parameters here is this value. Next, moving on to the LSTM layer where 100 is passed because we have set the neurons to 100 there, and these are the parameters there going on. And finally the dense layer we have set the output layer where it should give only 1. Okay, and it seems like in the third epoch we are getting the same. Okay, the accuracy is still constant, so it seems like it may not go above this. You have to change the parameters here or the values to increase your accuracy if you want high accuracy. So based on like trial and error method, you can modify it to find the apt batch size or epoch. Okay, batch like embedding size and vocabulary size, the best one you have set it, and it will increase your accuracy. And we are getting the same accuracy. We'll see this in the fourth epoch. So it is same, so no point in running further than this. So if you keep on running, it will still be in the same point, or it may decrease or increase. So once this 5 epoch is completed, this will complete. That will means like the model has been fitted, and that means the training part is complete. Then we can move on into the testing part. Our prediction. We'll run this. So it is about to complete, and it's the same. It's point to know 0.9295, and it will end now. 5 epochs have been completed. It is taking a little bit time to complete. In the meantime, we'll see about this. Okay, it is completed now. Okay, once you got this means the training part is complete and you are ready to go to the testing. The sequential have been run. This is the summary of it, and epochs have been run, and we got accuracy of this much. Okay, and there is a significant decrease in the loss, which means like if you keep on running, you may get increased accuracy with decreased loss. Finally, I am creating a variable answer where I am predicting it with the help of model.predict, and I am passing the testing part x valid, and I am setting a threshold of 0.5. What will happen is, if without this, I'll show you. I'll run this and print answer. We'll run this. Okay, this is the prediction and it is running. So once you complete the prediction, it should print, and see here we got many variables, but the output should be 0 or 1, right? But what is the prediction is? It is trying to give you the probability. Okay, so if it is above 0.5, you have to predict it as 1, or if it is below that, you can give it as 0. So we are converting it with the help of NumPy round option. So you can round that with the answer you are getting plus this value minus this. Okay, so that you can convert this to an integer. Once you convert it, it will turn around into 0 or 1. So once I run this, I can print the answer and see, and we will get zeros or ones in the output. Okay, and once you got this, what you can do is you can go for accuracy score calculation, and when you get the score, you can compare, and we are getting around 93.3% in this accuracy score in this testing data. Fine, this is how you can use machine learning models and neural networks also in sentiment analysis in this Twitter sentiment analysis project.